Hey guys, we are doing day 9 on determinants. To start us off, we've got our math meme of the day. Today our math meme is a little throwback to our days of fractions. So you'll notice the gentleman is represented by a third plus a half. And even though he is with the one he's supposed to be, right? We know that 1/3 plus 1/2, we need our common denominator. We need to double this guy. We need to triple this guy to get 2/6 plus 3/6. So really, he should be with 5/6, which is the girl that he's holding the hands with. But, well, Johnny over here, he got tempted by 2/5, because we all know that you guys are going to do 1 plus 1 and 2 plus 3, because you're like, that's how I do fractions, right, Miss Goldenberg? And then Miss Goldenberg cries, and a puppy dies. Going on a different, little bit more upbeat note, we are going to do some practice with our determinants. So this first one, I actually really like some of the ones like this, because they're a little bit more interesting. I'm asking you to do a determinant of a 2x2 matrix. And then your second and third warm-up questions are to write a matrix that does not have an inverse, and to give an example of a matrix and its inverse. So go ahead and pause the video, try these problems out on your own, and then unpause the video when you're ready to check your work. Okay, so here are answers for the warm-up. For the first one, evaluating the determinant, remember that's just AD minus BC. If you think about a 2x2 inverse, it's just what's in the denominator in that fraction coefficient. When we do this, we get 2x to the 4th minus 2x to the 4th, and lo and behold, we get a 0. So 0 is our determinant. Problem 2 in our warm-up was kind of nicely related to number 1, because they asked write a matrix that doesn't have an inverse. A matrix that doesn't have an inverse, number 1 is actually an example. So if you were lazy, you could have just been like, haha, number 1, Miss Goldenberg, I'm not doing more work. Miss Goldenberg says, good job, Jay. I feel like Jay in third period would be the one to see that. Probably Chase as well, right? Chase and Jay are good buds. If you guys are looking at that conic Excel sheet as well, I'm still working on getting you guys the voting thing to vote for the best ones and all that. But if you take a look at third period and look at Jay's, if you're in second period, you didn't see it then, probably. But if you look at it, Jay's is pretty trippy. It kind of looks like a mass hallucination or something like that. So take a look at Jay's conic, giving him a shout out to you guys. So from here, I want a matrix that doesn't have an inverse. That's when the AD minus BC is a 0, right? Because you can't have 1 over 0. That doesn't work. So basically anything that when you multiply across, you get the same thing, like 2 times 4 is 8 and 1 times 8 is 8. That's another example with just regular numbers. And then an example of a matrix and its inverse, Miss Goldenberg was going pretty lazy with this one. Her matrix is 1, 2, 3, 4. So for the inverse, following this step, if we look back up here at the top, there's your inverse formatting. I did 1 over 4 minus 6, which is a negative 2, so it's a negative 1/2. Switched the 1 and the 4, made the 2 and 3 negative or opposite sign of what they used to be. And then I did my scalar multiplication and distributed in my negative 1/2. Okay, moving on to new and fun things. Just a little bit of practice. So why don't you try this one on your own? I'm giving you a 2x2 matrix. I'm asking you to find the determinant, right? Sometimes I'll write it like that. Sometimes I'll write it like this. Sometimes it will be in words, either way. And then the next one is finding the inverse. Remember, these two processes are related. Also remember that finding the inverse of a 3x3 is a calculator skill. Finding the determinant of a 3x3, unfortunately, is you have to do by hand skill, but we don't do a ton of it, which is nice. So I'm going to pause the video and work out this problem. I want you to pause it as well and work out the problem, and then unpause when you're ready to check your answer. Haha! Did I trick any of you guys? I did the same thing as the warm-up. My determinant is 0, which means I don't have an inverse. If I was able to trick you and get you to do a ton of work, try and be a little bit more observant of the patterns that we're seeing, right? Patterns that we're seeing 1 times 6, 2 times 3, they make the same thing, just like my example with 8. So let's try something different. It's your favorite thing in the world. We are going to do a 3 by 3 determinant by hand. This reminds me, Maddie from second period, shout out to Maddie. Maddie said that in my beautiful notes from like yesterday, apparently the first ever, where did it go? Apparently like one of the first ever problems that I ever showed you how to do a determinant, apparently I had a typo. So apparently, where's my typo? I'll make it like yellow. Apparently when I multiplied, I decided that 1 times 3 was 21. So like this number was wrong in my work from yesterday, and here's my new answer. So shout out to Maddie for figuring out my typo, because that was pretty sad. The first ever 3 by 3 determinant, Miss Goldenberg couldn't multiply correctly. I'm hoping for a better one this time. So let's try this one out and see how we're doing. So remember a determinant, we are going to either expand across a row or we can expand across a column. Doesn't matter which row, which column, the process is the same and you will get the same answer no matter which one you choose. Now remember, there is a strategy of like if I pick these numbers, right? I'm going to always start with like 5, 3, 1 times a bunch of stuff. So I guess the only thing that you could do if you want more work is you could try and like pick smaller numbers theoretically. You will end up using all the numbers in this, so there's not really a benefit. It only really is useful when there's a 0 and you pick the row or column with a 0. I know that most of you probably are picking the first row. I'm going to pick the first column just to throw something different in there. So I'm going to write those 3 numbers, the 5, the 7, and the 10. If you want to do the first row or a different column, feel free to. I'm going to do this one. If you do a different one, you should get the same answer, which is nice. Remember, we have the number, then we have -1 raised to a power. And remember that the power that -1 is being raised to is the row plus the column space. So if I look at 5, 5 is in row 1, column 1, so 1 plus 1 is 2. 7 is in row 1, or excuse me, row 2, 1, 2 rows down, and first column, so that's going to be a 3. 10 is third row, first column, so 3 plus 1 is 4. And then we have to do our little 2 by 2 determinants. Remember, determinants have a straight up and down line rather than like the bar of matrices. This part is a little tricky to get at first. What you do for 5, you cross out everything else in 5's column and in 5's row. And these 4 numbers that are left, those are the 4 that are going to go here and populate that spot. Same thing is going to happen for 7. I'm going to cross out everything in its column and its row. So I have a 3, a 1, a 6, and a 3 left over. Same thing for 10. Cross off its column and row. These are my leftover numbers. Okay. So from here, it's going to be just a lot of scratch work. Remember, the big idea is all of these are going to be added. Let's see, the first one is 5. A negative raised to an even power, that's going to be a positive 1. If you want to fill in the other bits along with this, the numbers are the same. Remember, this is going to be a negative because it's to an odd power. This will be a positive 1. And here's where you're going to do your determinants. So 4 times 3 is 12, minus 6 times 2, which is 12. And hey, that's actually a pretty nice deal that Miss Goldenberg did for you guys. So that's 12 minus 12, which is a 0. So that means all this is going to go away, which is kind of nice. Next one, 3 times 3 is 9, minus 6. So 9 minus 6 is 3. I'll put that like up above to show how I got it. This next one, 6 minus 4. Okay, so the final work that's going to actually end up coming out of this is going to be a 7. I'll make it maybe a -7 just to streamline the process. Times a 3. Right, so that's going to be a -21. This one, 6 minus 4, that's going to be a 2. Right, 2 times 1 times 10, it's going to be 20. If we want to add these two guys, it's going to be a 41. is our final answer for our determinant. You should get the same answer no matter which row or which column you do. It's real good extra practice to just do another row or do another column if you're feeling like the 3x3 by hands are tricky. A couple people in office hours were like, Miss Goldenberg, why do we do this? And Miss Goldenberg was like, I feel that, because the textbook doesn't really talk a lot about it. You guys will get to use this fun process next year in pre-calc honors. Something to look forward to. I know you're like jumping for joy right now on your computer screening. The other thing that we were kind of thinking through is that a 3x3 inverse is something you use your calculator for. I believe if you tried to do the process by hand, it would involve a 3x3 determinant, kind of like finding the inverse of a 2x2 matrix involves the determinant of a 2x2. But your textbook doesn't do any of that by hand, so we can peruse the internet to verify this. Okay. Now, this one asks you to do the determinant, and it kind of goes along with the, like, if we compare, like, expanding down the first column versus expanding across the second row, if you kind of think about how those are going to compare, right, we kind of know in the back of our head they should be the same, right? So if you would like extra practice, you can do both. I'm going to ask you to think on your own for a sec, which one would be the best one to do if you want to be tactful and do less work, right? I feel like Olivia in my third period is nodding like, yes, Miss Goldenberg, we want to do less work. So, to pause the video, think to yourself about how you do it, and try and set up the problem. Unpause once you're ready, and I'll show you my setup. Okay, so I chose to do my first column. You also could have done your third row if you wanted. Both of these, if you look at what they have in common the orange bit, which is the 0. So you always want to choose a row or column with a 0 because it means way less work for you. Notice how I set up the initial first step of putting the numbers in my column. The negative 1 raised to the power, remember, for 2 it's squared because it's row 1 plus column 1. 1 is row 2 plus column 1. Row 3 is row 3 plus column 1, so that's where I got the powers. And then remember to get your determinants here. For 2, you cross up everything else in its row and column, and those 4 numbers are what populates over here. The one I think is probably the harder one to see, right? If you cross off everything else, it's these 2 and these 2. It's just kind of separated. Now notice for 0, you're doing 0 times some stuff, so you don't really need to do it. I even stopped sort of like writing it all out. If you wanted to, you could have, but really it's just going to go away anyway. So again, you also could have done row 3 if you wanted. I'm going to multiply this stuff out. So I've got 2 of 1. This is going to be a positive 1. This one's going to be a negative 1 based on even versus odd powers. 7 times 8 is 56, minus 6 times 4, which is 24. 24 minus 30. So this is going to be, let's see, that looks like 32. This is 6. So 32 times 2 is going to be 64. Remember, we're adding all these. Sometimes I just do like adding at the end. And then negative 6, we're going to add that. That's going to be 58. Looks like is my final answer. And looking at the time, let's see. I've got another practice with some zeros. And then in my next video, I'm going to do that practice probably. In video 2, I'm going to do practice with like which one is most strategic when there's zeros. And then we're going to talk about like a challenge problem or two that also involves like the strategy of looking for zeros. Okay, so that's what we're going to do in video 2, is a little bit more on being strategic. I'll see you guys in video 2.